For the last few years, the story of AI has been all about one thing, right? Bigger is always better. But today, we're diving into a fascinating, kind of radical idea, one that says the future of AI isn't about giants at all, but about something much, much smaller.
I mean, you look around and the whole industry seems to be in this frantic race. And the goal, it's always to build the largest, most powerful, most all-knowing language models you can possibly imagine. We see it every single day in the headlines.
Yeah, we're talking about the Goliaths of the tech world. These massive models are designed to do literally everything, from writing a sonnet to planning your vacation. And the assumption has always been, well, this is just the way forward. But what if that whole assumption is just wrong? What if for one of the most exciting and fastest growing areas in AI, the real revolution isn't about building one giant brain, but about creating millions of tiny, specialized ones? This is the wild idea we're going to unpack today.
So, where is this big shift happening? Well, it's in a field called Agentic AI. And this isn't about AI that can just chat with you. No, this is about AI that can act. And its adoption is exploding. We're talking over half of big companies are already using AI agents in some way.
Okay, so what is agentic AI? Let's break it down. Super simple, it's where AI graduates from being a conversationalist to being a doer. You give it a goal, and the AI itself figures out how to use software tools, follow a procedure, and actually execute a task to get it done.
And this diagram, it shows you exactly how it works. It's actually pretty brilliant. At the core, you've got a language model that acts like the brain, the controller. When you give it a task, its job is to figure out, okay, what tools do I need, in what order? And then it calls on those tools, whether that's another piece of software, an API, or even another AI, to actually get the job done.
And it's right here, inside these agentic systems, that the whole idea of going small gets really, really compelling. The source paper for this explainer lays out 3 massive advantages that small language models, or SLMs, have over those Goliaths we were just talking about.
So what are these big wins? Well, first, they're surprisingly powerful. Second, they're just a better fit for the job. And third, and this is a big one, they are dramatically more economical. Okay, let's dive into each one.
Okay, first up, power. You hear smaller model and you immediately think dumber model, right? Well, that's just not true anymore. We're seeing this new wave of SLMs that punch way above their weight. Now, you see parameters here. You can think of those as the number of knobs the model can turn to learn stuff. For a long time, more knobs meant smarter model. But now, you've got models like Salesforce's XLAM with 8 billion parameters outperforming giants like GPT-4o on specific tasks that are crucial for agents. It's wild. Small just doesn't mean weak anymore.
Second, suitability. I mean, think about it. Most of the jobs an AI agent has to do are pretty specific, kind of repetitive. You don't need a brilliant poet to classify an email. For these kinds of specialized tasks, a small expert model isn't just a compromise. It's actually a much better, more reliable fit than some giant, easily distracted generalist model.
And third, the economics. Just look at this number. Let it sink in for a second.
Yeah, that's right. It is 10 to 30 times cheaper to run a small model for a specific task inside an agent. This is not a small saving, folks. This is a game changer. We're talking massive reductions in cost, in how fast it responds, and in how much energy it uses. For any business, this is the difference between a cool demo and a product you can actually scale. But I know, it almost sounds too good to be true, which leads to a pretty fair question. Okay, let's just address the elephant in the room, shall we? This is the big pushback. Isn't a massive model, with its huge, broad understanding of the world, always going to be better, even on a tiny little task? And yeah, the paper calls us out directly. The belief is basically this. It comes from something called scaling laws, this observation we've had for years, that as you make models bigger, they just get smarter at everything. And it's a powerful argument, because you know what? For a long time, it was absolutely true.
But here's the first counter-argument from the paper. Those old rules, they don't apply anymore. Those scaling laws were based on a world where small models were just shrunken down versions of the big ones. That's not what's happening now. We have these totally new designs built from the ground up specifically to be small and efficient. They're not shrunken giants, they're purpose-built race cars.
And here's the second point, and honestly, it might be even more powerful. Agility. You can take one of these general small models, and with just a few hours of training on a single machine, you can turn it into a world-class expert at one specific thing. If you try to do that with a giant LLM, oh boy, you're talking weeks of time and a fortune in computing costs.
SLMs can become specialists on the cheap, and that is a massive, massive advantage in the real world.
So this isn't just some high-level theory, right? The paper lays out a super practical step-by-step guide for developers to actually switch their agents from using one big, expensive LLM to a whole system of these efficient little SLMs. Let's take a quick look at how they do it.
The whole process is really logical, and it's all about the data. First, you just start logging everything your agent does. Then you clean it up. Now, that third step, clustering, that's the magic moment. That's where you find all the repetitive little jobs that are just perfect for a specialist model. From there, it's pretty straightforward. You pick the right SLM for each job, you fine-tune it with your own data to make it an expert, and then you just keep feeding it new data to make it better and better over time. It's basically a blueprint for creating your own little army of AI experts.
So where does all of this lead? What's the big picture here? Well, if this shift really takes hold, the future of AI starts to look completely different. And the paper gives us this fantastic new metaphor for what's coming.
So you gotta let go of that picture in your head. The one with a single, massive, all-knowing AI, that digital Goliath that can do everything. That model is turning out to be incredibly expensive and, frankly, overkill for most of the real-world stuff we need AI agents to do.
Instead, picture this. The future is modular. It's like a Lego-like system. You've got thousands, maybe millions of these small, specialized expert models, the Davids, if you will, and you can just snap them together to build incredibly complex and capable systems. Each little Lego block just does one thing, but it does it perfectly.
And the benefits of this kind of future, they're huge. We're talking about AI systems that are way cheaper to run, that are faster to respond, that are more flexible when you need to update them, and ultimately that are more democratic. And why is that? Because building and using these small specialized models is something that way more people can do. Startups, developers, researchers, not just a handful of giant tech companies. And that leaves us with one last really big question to chew on. We've already seen what a few of these giant AI models can do, and it's amazing. But what new things become possible? What incredible innovations could we unlock in a world filled with millions of tiny, hyper-focused AI experts all working together? The potential there is just immense.